In this video, we're going to completely factor the polynomial f of x equals x cubed minus x squared minus 5x minus 3 using the fact that x equals 3 is a zero of this polynomial. Also, we're going to use this information to help us graph this polynomial. So we start off by dividing by x minus 3. Since x equals 3 is a zero, then we know x minus 3 divides in even with no remainder. We're going to use the synthetic division process. Since we're dividing by x minus 3, we place 3 off to the left. We place the coefficients of our polynomial next to it. Since it's 1x cubed minus 1x squared minus 5x minus 3, we place the coefficients 1, negative 5, negative 3. Then we use the synthetic division process. Carry down the 1, then take 1 times our value of 3 to give 3. We add negative 1 plus 3 to give us 2. Take 2 times 3 to give us 6. We place that in the next column. Add the column entries, negative 5 plus 6 to give us 1. Take 1 times 3 to give us 3, and then add the last column entries to give us 0, which is our remainder. The numbers at the bottom give us the coefficients of our answer, 1x squared plus 2x plus 1. So this means f of x equals x minus 3 times x squared plus 2x plus 1. We can factor x squared plus 2x plus 1 as x plus 1 times x plus 1. So we can write f of x as x minus 3 times x plus 1 times x plus 1. Or we can write it as f of x equals x minus 3 times x plus 1 quantity squared. Now we can use this form of the polynomial to help us graph this. To find the x-intercepts, we let the polynomial equal 0 since y equals 0. And we get 0 equal x minus 3 times x plus 1 times x plus 1. Well, by the zero product law, remember that if a product equals 0, that implies that each factor equals 0. So x minus 3 equals 0, x plus 1 equals 0. This gives us x values of 3 and negative 1. So our x-intercepts are 3, 0, and negative 1, 0. And now we can proceed on to graphing this. And I'm going to use the factored form y equals x minus 3 times x plus 1 quantity squared. Okay, we've already established the fact that 3, 0 is one x-intercept and negative 1, 0 is another x-intercept because these are the values of x that result in y equals 0. So we plot these 2 points, negative 1, 0 and 3, 0. Now we're going to need to find some more points on each side of each of these intercepts. So let's find some more points. When x equals negative 2, we get negative 2 minus 3 is negative 5, and negative 2 plus 1 is negative 1 squared makes positive 1. Negative 5 times positive 1 is negative 5. So we have the point negative 2, negative 5. When x is 0, we get negative 3 times 1 squared is just negative 3 times 1, or negative 3. When x is 1, we get 1 minus 3 is negative 2 times 2 squared, which is 4. Negative 2 times 4 is negative 8. When x is 2, we get 2 minus 3 is negative 1 times 2 plus 1 squared is 3 squared, or 9. Negative 1 times 9 is negative 9. And when x is 4, we get 4 minus 3 is 1 times 4 plus 1 squared is 5 squared. 1 times 5 squared is 25. So now let's plot these points. We plot negative 2, negative 5. We plot 0, negative 3. We plot 1, negative 8. We plot 2, negative 9, which is just barely on our graph here. And then 4, 25 is off the map here, so I'm going to leave it off. And now we draw a smooth curve through from left to right. I'm just going to do this in segments here. Okay, we're going up towards our x-intercept, then we're heading down and continuing down, almost bottom out here, and we're heading up toward the other x-intercept, and then we're heading almost straight up at 4, up to the point 425, and that's what I get. I'll superimpose the actual graph on just to show you that we're pretty close.